Hi friends, welcome to follow up. In this video, we are going to share a variant of a interview question. So here the question is the following. So we are given a utility function called line-plane intersection. So this utility function is written here. It computes the intersection of a straight intersection point of a straight line and a plane. So the task is to write two functions for batch computation. So we compute the intersection point for a set of straight lines and a set of planes. So one is using for loop and the other using vectorization. So first I'm going to explain to you the line-plane intersection function, and then we implement one using the for loop because this is very simple. And the second one, it's required to use vectorization. So we are going to leave it to you as exercise. If you have difficulty in finishing the second function, so you are welcome to comment or contact with me. So here the first function is a line-plane intersection. So here we first imported numpy. So because here this interview question is essentially test or measure how the candidates are familiar with numpy. So here the line-plane function accepts these four arguments: x, y, c, and p. So x and y determines the straight line. So here x is a three-dimensional vector. You can understand like this. It's denoting a point in the line. And the y is a direction. So in other words, the line is something like this. So x is a generic point in the line, then minus this little x, the point here. It's a fixed point. It will parallel to a y. So actually you can write a parameter equation for this straight line. So C and P determine the plane. So C is you can also understand it as a three-dimensional vector. It's a point in the plane, and P is the normal direction of the plane. So the plane equation actually can be written like this: x is the generic point in the plane, so minus this point in plane, that is C. Then if we do inner product with this normal direction P, we are going to have 0, right? So here the return is the intersection point, or the coordinate of the intersection point. So by computation, this point will be given by this capital I. So let me first explain how we get this expression, that is this part, x plus the coefficient times v. So here if we assume that the plane equation, this the parameter form, is capital X minus little x equals t times v. So t is a scalar, it's a parameter. V is the direction, right? So this is the line equation. And then the plane equation is this one: x minus c dot product with p is going to be 0, right? And then if we put capital X equals little x plus this t times v. So this is from the line equation. If we put it into the plane equation, we're going to get this expression. So notice that this bracket, it means dot product. So you can do the algebra to get t, the specific t. We denote it by t naught. It's going to be c minus x dot product with p divided by v dot with p, right? So therefore you computed t naught, then you can get the intersection point, right? That is x plus t naught times v. So x plus t naught times v is exactly this part. So in other words, the expression here. So this is the utility function. We assume that this function is given. So our task is to write two functions to make the computations in a batched fashion. In other words, we're given n lines and m planes. So we want to find all the intersection points. So here the return is ND array of shape n times m times 3, right? So n is the number of lines and m is the number of planes, right? So this is the one requirement. And another requirement is that we want to write this function using vectorization, right? So here is this is the x and y is of shape n times 3, and c and p is of shape m times 3. So we want to return this one. So your code or your implementations should pass some test case. So here I wrote some customer test case. So notice that we need to pay attention to the here, right? We need that v and p are not perpendicular to each other, so that we do not have division by 0 issue. So we can assume this, and then the task is to implement these two functions here and here. So for the first one, I guess most people who have experience in using numpy might be not that hard. So for this purpose here, we give a quick implementation. But for the second one, we leave it to you as exercise. So this is actually a very good exercise, right? So you can try. So this second one is by no means trivial. It actually tests your familiarity with numpy. So for the first one, we know the return shape is n by m by 3. So we can initialize a result that is an NP array. So we can assume it's NP 1s or 0s, but it does not matter. So this is just the initialization. So this is the shape. And the first, we're going to get the n and m. So we can call x and or c shape to get the n and m. Then we can use a for loop. So here we have this I in this range, right, and the j in this range. Then we can get the little x, little v. That is the these two two pieces of information determines the straight line, and c and p determine the plane. So then we can call the utility function to get the intersection point, and then we set the corresponding vector at index ij to be temp, and then we return this result. And that's basically a very straightforward one. So basically some very verbose. And the second one requires some thought and familiarity with tensor operations, right? So the tensor operations or vectorizations are actually very important for data analytics or for machine learning, like you use PyTorch or TensorFlow or some other frameworks. So here for this part, I will leave you as an exercise. So here are some test cases. So actually you can also write some test cases after you do the implementation. So with that said, basically that's about it for this video. Thank you.